So this is Lab 1, which is charge tape, and my name is Kayla Carneal. So for an introduction, the purpose of the lab was to conduct an experiment that determines the amount of excess charge on one piece of tape, as well as calculating the electron deficiency and atom to electron ratio. The fundamental physical principles include Coulomb's law, due to the tape acting as point charges, and Newton's second law. We're going to be using a free body diagram in order to balance the gravitational force. So the main physics ideas include force balances, modeling of point charges, and that the tape has an equal and distributed charge. The distances and dimensions measured can be used in Coulomb's law, which I have pictured below. The dimensions of an atom can also be used to calculate excess charge. So here are the results overview. The charged pieces of tape repelled one another. They were attracted to my hand. The piece of tape was attracted to a neutral object, and each piece of tape had a deficiency of electrons of 7.935 times 10 to the 10th. The charge of each piece of tape was 1.2696 times 10 to the negative 8th, and the ratio of atoms and electrons was 5.5556 times 10 to the 6th. So the actual experiment assumes negligible air resistance, the tape is a point charge, and the charge is evenly distributed. The figure showing here has tape B as the system and tape A as the surroundings. The initial conditions were that a piece of tape was on my desk around 8 inches long, with another piece of tape stuck on top of it. These both had handles in order to create the charged piece of tape. The details are I first created a piece of charged tape by placing it on top as said earlier, and as well as in this figure right here that I pictured. I quickly ripped it off and stuck it on a desk where it could hang and observe that it was attracted to my hand. I then did this with 2 more pieces of tape using the same technique, and I noticed that they repelled one another. I then compared this piece of tape to a neutral book, and I saw that there was an attraction. So here's a photo of them repelling one another. I then negatively charged a plastic pen by rubbing it on clothing, created another piece of charged tape, and I saw that they were attracted to one another. This means that the tape must be positively charged. Lastly, I placed tape B above tape A as seen in the figure earlier. These were both charged until a portion of the tape began to float, and calculated and measured this distance. So here is the data collected. I have the tape length, the tape width, the distance in between them, the mass of the tape, and then I have the area seen here, which is just the length times the width, and the area of an atom, in which I got the width from AAT BioQuest and then squared it. So here are my calculations. I have a free body diagram drawn over here of tape B. Because it's not accelerating, the electric force and the gravitational force must be equal. So calculating the gravitational force was mass times acceleration, which was 9.8 meters per second squared. Here's that gravitational force. The 2 charges are equal, so the 2 Q's could turn into just Q squared using the electric force, Coulomb's law. And then I set the gravitational force equal to Coulomb's law, isolated Q, and took the square root to get the charge of one piece of tape. Here are my other calculations. So I could get the electrons lost by one piece of tape by dividing this charge by the charge of an electron, 1.6 times 10 to the negative 19th coulombs. I then could get the atoms on one piece of tape by dividing the surface area of the tape by the surface area of an atom. And then I could get the Fresnel ratio of atoms and electrons by dividing this amount of atoms by that amount of electrons. So here's my actual coding output. As you can see down here with all the printed scripts, they are accurate to my hand calculations. And then here is my model. The red is the gravitational force and the orange is the electric. So I first put in the data I collected, and then I calculated the gravitational force and the charge just as I did earlier. I then got the electron deficiency by dividing by the electron charge. I got the amount of atoms and the atom ratio. I then printed all of the results in writing, and then I created the actual model that you see, and I created the gravitational and electric force down here. So to discuss this, the code assumes an absolute perfect point charge, which is not true in reality, and it also assumes that no charge was lost from my hand. These are both also possible sources of error. Other possible sources is that the charge may not have been evenly distributed, and the tapes might have had different charges that could not be equated to Q squared. So what if electrons had positive charge and protons had negative? My observations would be exactly the same, because like charges are still going to repel and unlike charges are still going to attract. Why is it important to handle the charged tapes as little as possible? This is because charge is lost due to interactions with my hand. And then here are just those final conclusions once again. I was able to successfully model this and see the electrons lost and the charge between 2 pieces of tape. Thanks so much for watching.